Okay, example 2. You certainly saw these last year. A rectangular garden measures 15 by 24. 15, 24 meters. A larger garden is to be made by increasing each side length by the same amount. The resulting area of the whole thing is going to be 1.5 times that of the original area. The original area is 15 times 24. That's 360. So there's my original area. Once I add to this garden, the area is going to become 1.5 times the size of this one. We need to find the dimensions of the new garden to the nearest hundredth of a meter. Okay, so here's my old garden. I'm going to add some amount in each direction, the same amount it says. Like this. And you probably remember you did questions like this last year where you would put a border around something. Okay, so we don't know how much we're adding, but whatever it is that we're adding, it's the same amount. So I'm adding x in this direction, x in this direction, x. Okay. All right, so now the area of the new garden would be this length times this width. Okay, so let's come up with a new expression. We have 15 by 24 for the original garden. So what's the width of the new larger garden? Well, this part of it is 24 still. We added x here and we added x here. So from here all the way to here is x plus 24 plus x. Or 24 plus 2x. When I look this way, I can see that this is still 15, it always was. But to this 15 meter width, I've added x this way and x this way. So the new width is 15 plus x plus x. Okay, that's our picture. Now we need an area function. Okay, well, area is length times width. And because we're interested in the dimensions of the new garden, I'm going to replace area with the dimensions of the new garden. And that is 360 times 1.5. It said in the question that once I expand the size of this garden, my area will be the original garden's area times 1.5. My length my length now is 24 plus 2x, and my width now is 15 plus 2x. That's the length and the width that creates this area. Okay, so now go ahead and expand. Pause the video for a second and expand it yourself, and then we'll come and check. Okay, did you get this? And once you put 0 on one side, you should come up with this. And then you can common factor that a little bit. So when you got to there, hopefully you considered your next step. Could you factor, come up with two things that multiply to negative 180 and add to 39? That's a bit of a task. So let's jump right to quadratic formula. And when you do, this is your A, your B, your C, and you're finding your X value immediately. So negative b plus or minus the square root of b squared minus 4ac over 2a. Hopefully you got that, and when you punch it all into your calculator and use the plus, you will get 2.085, and then punch it into your calculator again using the minus, and you'll get negative 21.59. Okay. X2 is negative. This guy's looking a little sus to me, because if I put a fairly large negative number into either one of these, I'm just going to test it on the width. 15 plus 2 times negative 21.59. Clearly that's going to become negative. Even if I disregard the 0.59, twice negative 21 is negative 42 point whatever, 0.3 or whatever. But clearly that's negative. And that can't be, because we cannot add a negative amount of meters to the length and width. So disregard. That's garbage. Okay, now we're only happy with this solution, which means we can find the dimensions. Let's go up here. Therefore, dimensions of the new garden are, plugging in the x value that we like into our length and width expressions, we get 28.17 meters by, that's the length and the width, plug in the x value that we're happy with, 19.17 meters. There you go, dimensions of the new garden.